Hello, this is Andrew Minahan. This is my final project for hydrogeology. My townships will be Centerville and Meeme in Manitowoc County. Manitowoc County is located just south of Brown County and just south of Green Bay, as Green Bay is indicated by the star on the Wisconsin map on the left. My townships are Meeme and Centerville, and those are going to be in the south-southeast of Manitowoc County. This is a rural area in Manitowoc County, and what we're going to see is heavy glacial till on top, followed by a dolostone confined aquifer, which is where the wells get their water from below. As for the glacial till, this is part of the Holy Hill and Kewaunee formations, and a recessional moraine is formed, which is called the Kettle Moraine, to the west, which is where we're going to get our elevation change from. This moraine was formed at the end of the Wisconsin glaciation about 18,000 years ago to 15,000 years ago. When we normally think of these dolomite aquifers in eastern Wisconsin, we generally think of unconfined aquifers. This one, however, that glacial till protects it and kind of makes it a semi-confined aquifer with a little bit of leakage, but for the most part it is confined. The rocks in the area of my project are Silurian dolomite, and they form the Engadine Formation and the Manistee Formation, as well as the Burnt Bluff and Mayville, but those are going to be below the aquifer and the wells I'm looking at. And these rocks are part of the Michigan Basin, which is this photo up here in the top corner. You kind of see that bullseye pattern around the state of Michigan. That's going to be the Michigan Basin, and the purple Silurian rocks are the rocks that this aquifer is in. This is a more zoomed in map of the area we were looking at before. On the left here in Calumet County, where these drumlin arrows are, that's where your exposed dolomite's going to be, and this is where the bulk of your recharge is going to be, with a higher hydraulic head over here on the left. As well as in these gravel sands, you're going to get a bit of recharge. But then in my section, which is outlined in this black rectangle, you're going to get a lot less recharge because the water just can't get through this confining glacial clay layer. So your recharge is going to come from the left in Calumet County in the west, and then that's going to go underneath the clay and the dolomite here in the east. This is the map I have constructed using the Wisconsin DNR's well construction reports. As you can see there on the left, we have higher hydraulic head that's up towards the moraine. And then down towards the lake on the east, we're going to have much lower hydraulic head. So west to east is the flow in this aquifer. One more thing to take note, this orange line through the center of the map, that's going to be where my cross section is. That's County Road X. This is the exact same map, but I've gotten rid of the wells just to make it a little bit more clean and easy to read. As you can see, it's the same thing where up on the left you got that higher hydraulic head, and then if you go towards the right, towards the east, you get lower hydraulic head, and I put in some flow arrows there to help visualize. This is one of my cross sections. Let's start at the bottom where you get that light gray and a little darker gray. That's going to be your Silurian dolomite. That's where the aquifer and the fractures are. The light gray stuff, that's the Engadine Formation. Unfortunately, there's not really too much data, and certainly none in the well construction logs that tell us where this Engadine Formation ends and the Mystique and Burnt Bluff begin. So I kind of just made an estimate based on the USGS's data, which about 100 to 80 feet, but take that with a grain of salt. But up towards the top on the till, this yellow, purple, and brown layer, that's going to be your clay and lake sediments. That's going to be confining. There's not going to be a whole lot of water that can get through that, as well as the pink over here on the left. But this dark gray gravel and sand outwash, that's going to allow for a lot more water, as well for wells to be drilled and get water from that area. And we do see that. We have some wells that were able to get water out of gravel-bearing water. Unfortunately, a lot of the older ones had gone dry, so we're not exactly sure as to how sustainable that is. This is the exact same cross section, except this time I have added the wells as to where I got my data from. The dotted line is also the potentiometric surface, so those numbers on the hydraulic head, just in case you were wondering as to where that was. When we generally think of the dolomite aquifer, especially in Kewaunee and Dorr in northern Manitowoc County, we generally think of those nitrates and bacteria as causing problems. But luckily, that deep layer of glacier till protects a lot from those nitrates and bacteria. In fact, there are 4 concentrated animal feeding operations in these 2 townships. I looked up all 4 of them with the DNR's network and found that none of them had nitrates or bacteria above the legal limit. Obviously, with this being a dolomite aquifer, the water is going to be quite hard. I believe in our 2 townships here on the map it says 300 and 400 milligrams per liter. Generally, the accepted amount you want to shoot for when you have a domestic well is 100 milligrams per liter. But this isn't a massive deal compared to, say, nitrates or arsenic. So sulfate data is a little bit more spotty, but it definitely is present. I live in Centerville and I have found that our wells do have a lot of sulfate sometimes in them. But using the small amount of data that we did have in these 2 townships, I did put 2 little dots here. The red dot has an average of about 214 milligrams per liter in the Centerville Township and 28.5 milligrams per liter in the Meeme Township. So I believe the legal limit in Wisconsin for sulfates is 250 milligrams per liter, so none of that is exceeding that, making this much more of an annoyance, but it still could be a problem for somebody who's sensitive. Also, these sulfates generally seem to be forming towards the lake rather than towards the moraine. As for sustainability within this aquifer, it seems to be of low concern, especially when you compare it to other areas in northeast Wisconsin like Kewaunee, Dorr, and the St. Peter Sandstone aquifer. This doesn't seem to have many of those problems. You kind of get the best of both worlds, where you don't get those unconfined problems where you get nitrates and agricultural runoff, but at the same time you don't get those deep confined aquifer problems like heavy metals. I would say the biggest problem with this aquifer is that there's a lack of information on stuff like strontium and sulfates. But nevertheless, I'd say this aquifer, with the data we know, is in pretty good shape.